Welcome. We're going to revisit the distance formula and work with perpendiculars to determine distance. So let me show you what I mean. First, let's do a reminder that the distance formula is that the distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Remembering that inside the parentheses we're subtracting, we're squaring both of those, and then we add those results. Now over here, we are going to pick, or set up points. Let's use the points 1, 5, and negative 2, 2. So the distance for this, so they're all up, and let's just put those things in. So x2 and y2 are here, so we'll lead off with those. Negative 2 minus 1, so that's x2 and x1 squared plus y2, which is 2, minus 5, and that's squared. So negative 2 minus 1 is negative 3, and when you square that, you get 9. In fact, I'm going to write this so I have a little more space there. So square root of, well, I'll do negative 3 squared is 9, plus 2 take away 5 is negative 3, and that's going to be squared, so it's another 9. So that's equal to square root of 18. And with the square root of 18, we have two possible answers. We can take the square root of 18 and break it down into, inside the square root, we have a 9 and a 2. And the 9 is 3 squared, so that'll come out and go in front as a 3. All right, so that's one thing. So we have 3 square root of 2. That's an exact answer. If we put in the calculator, we get an approximate answer of 4.2 units. So both of these are correct depending upon which it is that you're trying to get. Let me mark them as the correct answers. And underneath it, I'm going to write that's an exact answer because it has not needed to be rounded, or if it was a number that could be changed, like 1/2 made into 0.5, that's a decimal, but it doesn't need rounding. And so this is the approximate answer. There is another way to look at finding the distance too, and that is to use 2 points to make a right triangle. So I'm going to do an approximate little graph here and find that 1 and 1, 2, 3, 4, 5 is, say, about here. And negative 2 and 2 is about here. So we want to find this distance here. That's what we're looking for. What's the distance? This point is negative 2, 2. So what we're going to do is we're going to make a right triangle. And when I look at the right triangle, I see that there's a 1, 2, 3 spaces this way, and 1, 2, and 3. There's 3 spaces this way. So because that's a right triangle, we can use that fact that a squared, we'll call this one A, and we'll call this one B, and then the distance is C. A squared plus B squared equals C squared. So we have 3 squared plus 3 squared equals C squared. 9 plus 9 equals C squared. 18 equals C squared. I'm going to switch them just because I like to have that in there. So C is equal to, now when we take the square root of 2 sides, we are usually doing plus or minus because there can be a negative to it. However, because we are dealing with an actual distance, that means we can't use the negative because there are no negative differences. It doesn't mean go backwards and doesn't mean take away from it. It just means that in a distance, there's just a certain amount of space and it's always a positive space number. And then this happens to be the same place we're at before. So C is 3 root 2, which is approximately 4.2. And I should write units on both of those. And so both of those are correct for the same reasons above. I'm going to write units under here for that one. So that's an alternate method. If you are able to graph 2 points, and you choose to, you can use that to find the distance between the 2 points. Now, the distance formula actually derives from the Pythagorean theorem. So in a way, they're the two things. They're just looking at two, or they're the same thing. They're just looking at two ways of doing the same thing. All right, so here, the basic concept here, we're going to find the shortest distance between a point and a line. Here's what this looks like. Let's take a line like this. I'll call the point that's here A and the point here B. So we have a line which is AB. And then here I have another line. Well, actually, before we make the line, let's put a point here, P. Okay, I'm going to call this one P1. And the reason is because I'm then going to draw a line that is perpendicular and then makes a point P2. So we want to know is the distance from P1 to P2, because that's the shortest distance from this point going all the way to the line. If it wasn't a right angle, it would be, if it was more or less, then that means it would be a longer line. So for instance, if we went out to here, that line is longer than the one that's the right angle. If we went down to here, that line is longer. So anywhere else you draw the line, it's going to be a longer distance between the point and the line. So the shortest distance is always the right angle or perpendicular line to the line. So the point that we drew here is point P1, and then we did point P2. That one, though, is not the point that we're talking about to find. So what we need is, what's this distance? Let's take a look at an example of what to do with this. So given the line that goes through 0, 0, and negative 5, 5, what's the shortest distance from point 1, 5 to that line? So I'm going to do a little graph of it here. And 1, 2, I think I can go a little further with those. 2, 3, 4, 5. 1, 2, 3, 4, 5. So 0, 0 is 1 point. Negative 5 and 5 is the next point. That's negative 5 and that's 5. Okay. So that's the line. And because they said line, it's actually a line like this. Oh no, I want to keep that. And now the point that we're looking at is 1 and 5. So 1, 2, 3, 4, 5. So that means that 1 and 5 is about here. So what we need is the right angle to it. So that's going to be approximately, I can't tell exactly by drawing it. I'm going to have to do it algebraically in order to get this right. We'll say so. So look at what I've constructed here, where this looks like a right angle, and I'm going to say it is. It's just that maybe a little off by drawing, but I'll be able to get it correct by doing this. The shortest distance, so this is point P, and we'll call this one P2. So I'm going to call it P1. And what we want is this distance here. So there are three parts to this. The first thing that we're going to do is to find the equation of line 1. All right, let's number these lines. This is line 1. Okay. This is line 2. Okay, so we have line 1 and line 2. The first thing we need to do is to find the equation of line 1. All right, we'll put this into y equals mx plus b form. We could use the point slope form instead of the slope intercept form, but I'm going to use the slope intercept form for this. So for the first thing we need to do is find the slope. M equals, and so this is x, let's see, x, nope, I can't draw it out there. X2, Y2, because it's second pair, X1, Y1. So the slope is -5, oops, Y is on top. So it's 5 minus 0, and -5 minus 0, which is 5 over -5, which is -1. So what's that mean? We now currently have y equals, for mx plus b, y equals -1x plus b. But notice that this point's 0, 0. So we can see that we are crossing the y-axis at 0, 0, which means that that's the y-intercept. So we can put a 0 in here. And so if y equals, well, -1x is what we usually do, is just -x plus 0, but we don't usually put the plus 0. So when that's 0, that means we'll just write y equals -x. Now, this is not mathematically wrong. It's just not common. That means that this is the first step that we want to do. I'll call it L1 there. All right, now let's look at doing L2. So we found the equation of L1. That's step 1. I'm going to write that here. Step 1. Find the equation of L1. Now, step 2. And I'll take some space over here. Yeah, I got lots of room left, it looks like. There are 4 steps to this. So what I'm going to do here is step 2. Find the equation of L2. Okay, that one's going to take a little bit more work. So let's see, whoops. I need to write it as step 2. Now, the drawing of the graph was not a step. It's completely optional. You don't really have to do the graph. It helps me enormously. It helps most people enormously. So it is a good way to do this kind of a problem. So I recommend it. But the step 1, step 2, step 3, step 4 are pretty essential here. So what we need is to find the slope. All right, so that means we need, now, L1 is perpendicular to L2. Because they're perpendicular, then that means slopes are opposite reciprocal. So one of the slopes is a -1. You know that from up here. So -1, it's essentially -1 over 1. So what we are going to do is first that the negative goes away. Okay, so the new one becomes positive. So it's not an equal sign here. It's just an arrow. The new one becomes positive, and we switch 1 over 1, which isn't really much switching. It's still 1. So the -1 slope changes to a +1 slope, since 1 is its own reciprocal. Okay, now we know that. So that means we know that y equals 1x plus b. We won't really need the 1 there anymore, but we know it's there. Now what we need to do is to find the b. So we will take this point, and for the slope of this line here, we know it's already a +1. Now we'll put that 1 and 5 in. 5 is the y. 1 times 1 plus b. So that's 5 equals 1 plus b. Let's subtract the 1, and we get 4 is b. So that means y equals x plus 4 is our second equation. So we have two equations to work with here. That's L2. Okay. So we have L1 and L2. Now, what we're going to do is solve the system of equations. 3, solve this system. And the system is two equations. So we have y equals negative x, and we have y equals x plus 4. Oops, want to put a 4 there. Now we can do this numerous ways. There's different ways of elimination. It'd be easy to do that here. We could just add these together, or we could do substitution. So by one of the ways to do it would be to take the fact that y equals y, and we'd do negative x equals x plus 4. And then subtract the x's, we get negative 2x equals 4, x is negative 2. The other thing we can do here is we can add these. Because this is a negative here, and this one's a positive, right this moment we can add these together, and we get 2y is equal to, the x's cancel out, negative x plus x, 4. So that means we get the y equals 2. If we put 2 back in here, we get x is negative 2, and the same thing that we got here. So that means that we got the point. So P2 is the point of negative 2 and 2. Now, actually, that takes a short bit of explaining here as to what I'm meaning by it. I think I'll put around that. What we were trying to do to solve the system, the reason that this is a step is because that gives us this point. Okay, find the point of intersection, which is P2. That's what we're trying to find now, and we can do that by solving this. And we just did. So that's P2. Now the fourth step is to find the distance. We want to find this distance here. Oops, went too far. We want to find this distance between P1 and P2. Let's come down here. Fourth step. From P1 to P2. And that's going to be using the 2 points. I guess I'll put the 2 points under here. Negative 2, 2 is P2, and P1 was 1 and 5. Okay. So since there's a 2 on here, I'll call these the x2 and the y2. And so what we're going to do is find the normal things. Let's first find the slope. Okay. And that means y minus y over x minus x. Oops. I'm going to write out y2 minus y1, x2 minus x1. Based on this, then, that means it's positive 2. y2 is a positive 2. And subtracting the y of the P1, 5. And then the x of the P2 minus the x of the P1. So we get negative 3 minus and minus makes a positive 3. Ooh, wait a minute, I'm finding the slope. Okay, no, negative 3. So we got a slope of 1. Oh, but we already knew that. So I'm doing that and realizing we already got that. Oh, wait a minute, that was negative 1. And then that caused us down here to do reciprocal, opposite reciprocal. So I don't need to find the slope because that's not going to help me find the distance. Instead, do the distance as square root of 1x minus the other x squared plus 1y minus the other y squared. So that's what should have been put in here. It doesn't hurt to have done the slope and verify that it really is the correct slope. Now let's go ahead and plug in the things we need to here. So that x2 is minus 2 minus 1 squared plus y2 is, where am I here? y2, there, yeah. y2 is that one, so it's 2 minus 5 squared. I'll come over here. At the distance, this is negative 3 squared, which is a 9. This is negative 3 squared, which is another positive 9. That's square root of 18. So the distance equals 3 root 2 units, or 4.2 units. And those then would be the answers for exact or approximate. So just like what we did before, and I did the other problem, what we were doing, let's go back up. Well, what I did is I found 1, 5 to negative 2, 2, without telling you that those were going to be the points that was in this problem. But we had to find that that was negative 2 and 2 by doing this process. If you want to have the first problem with you all the time. All right, so now we've got our two answers to this one. This is the kind of thing where usually the approximate answer may be better because it gives people more of a real sense of what the distance actually is. And the exact answer, because it has a square root in it, we don't recognize that as a practical number easily. So the other one would be a better answer usually, unless you're told to do one way or the other. All right, now let's take a look at this example where you're given the two lines, and we're going to find the distance between parallel lines, not the perpendicular line. So let's take a look at what this is like on the graph, graph-wise. Okay, so I will set it up here as an idea, like so. So here, I need to change this one around, move the x over, 2x plus 1. So I subtracted 2x from both sides. And then you can't have the y being negative, so I'll subtract or divide everything by the negative 1. And I get that y is equal to 2x minus 1. All right, so let's start with this one, which is a positive 3. Oops, let's number these. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. All right, might or might not be enough. We don't know until we've done some of these. But let's see. So first one, we'll go to positive 3. Ooh, I need a few more points. That's because of the fact that we have a slope of 2 over 1. So I'll go up 2 and over 1. Or I could do both negatives and go the other way. But now I have a straight line. And then next, now, I have negative 1 for where I'll start with, and a slope of 2. Same thing, 1, 2, and 2. 1, 2, and 2. So we actually have, now you can see, perpendicular lines. So what we're going to do next is we are going to go and we're going to figure out what's the distance between them. Okay, so we want the distance. I think that needs to be written. Distance. So there's a C missing. So distance between two parallel lines. So we could basically draw perpendicular lines like this, and that would be the shortest distance. And we could do that anywhere on here, any of these places. I will tell you right now, the easiest place to draw the line is going to be the one that goes through the x-axis at a particular point, or y-axis at a particular point. So I'm going to guess that one's perpendicular. So it's approximately like this. So what we want is this distance. Now, think about what we have here. We know the point, which is 0, 3, because it's the y-intercept from that line. we can find the slope, or in fact, we know the slope. I'll call this one, oh, we have to name the lines. So this one's L1, this one's L2, and this one will be L3. So we know the slope of L3 because it's perpendicular to the others, and they both have the slope of 2. So 2 becomes a -1/2. So we know those two things. So we can make an equation of the line, but do we actually need that now? Well, yeah, it actually can be useful, because what it'll do is, what we need, like the last problem, is we need this point so that we can then use the distance formula for here. Extend that a little bit. We want the distance formula between those 2 points. And we already know this one. All right, so we know, I'll put it in green again. That point is 0, 3, but we don't know what the other point is. So we need to find that point before we can use the distance formula. All right. So step 1 for us will be to find equation of L3. So y equals mx plus b. Well, we know that the slope is -1/2, and we know that the y-intercept, because it goes through there, is 3. So we don't even have to do any calculating. We just have it right there. All right. Now, next, let's see. So let me draw a line here. I want to make sure we have enough space because I have 2 more big steps here. So I'll do step 2 starting about here. Find P2, because I should call this one P2. That one's 0.1, that one's 0.2. Find P2. Okay. So that's an intersection between 2 lines. Okay, so if we're going to find that one, okay, we're going to need the equation of line, need equations of L2 and L3. We now have them. L2 was given to us right here. So let me bring this back down. 2x minus y equals 1 is one equation, and we just came up with the other equation. Y equals -1/2 x plus 3. So I have a couple of things I can do. I could, in this case, I could change this around to set 2 y's equal, or I can take this and substitute it. I think I'll do the substitution one right now. 2x minus, oh, I have to be careful here with this, how I set this up. Okay, so this was the y, but you had to be careful that it's subtracting everything that's in it. So let's clean that up there. This is going to be 2x plus 1/2, because we're going to multiply negative times negative. Then we're going to do a negative times a plus. So that's 1/2 x. Let me fix the 2 here. And x, that's going to be -3 is equal to 1. Let's get rid of that denominator by multiplying everything on all sides by 2. So we get 4x plus x minus 6. 2 times -3 will be 6, and equals 2. So think of it in terms of this. 2 times 2 is 4. 2 times 1/2 is a 1 in front of the x. 2 times -3 is the -6. And 2 times the 1 on the other side is the 2. We'll put these together as 5x minus 6 equals 2. I'll add 6. 5x equals 8. And when I divide by 5, I get x is equal, well, 8 over 5. But let's make that a decimal because it doesn't need, oops, it's not 3, it's 6, 1.6. It doesn't need to be rounded because it ends right there. So we've just found 1.6. Now we need to find the y. And for that, we can just put that 1.6 into one of these. Let's take what looks to me like the easier one for it. Right, so 2 times 1.6, it might not be, but I'll put it in anyway and we'll see. All right, 2 times 1.6 minus y is equal to 1. So that's 3.8 minus y equals 1. Ooh, we're going to subtract 3.8. Okay, that is a little bit harder here. We get negative y equals, that's actually a negative 2.2. And divide by the negative 1 and get y is equal to 2.2. Putting in the other one might have been easier because but it would have been almost the same kind of subtraction. So we have a point of 1.6 and 2.2. Sort of an interesting x and y point, but it's a legitimate one here. So because now we can use it. It does approximately look like where it's more than 1, less than 2, so it's an in-between place there. And now I can put that in as 1.6 and 2.2. Now let's do the distance formula. That's the last part, because now we have 2 points. Distance from, and the first point is this 0, 3. From 0, 3 to 1.6 and 2.2. So distance is equal to the square root of 1.6, actually 0 plus. I'll do this right from the beginning. 0 plus 1.6, because it doesn't have to be the 2 here. Wait a minute. I've got to be careful. I was so busy trying to do this. Let's make it minus like it should be. 0 minus 1.6 squared plus 3 minus 2.2 squared. Okay. So if I were to negative 1.6 squared would actually be like 2.56 plus, and then 3 minus 2.2 is negative 0.8, and that would become 0.64. So the distance is equal to the square root of 3.2, which is approximately 1.8 units. Let's check. Did it say units at top or anything? It didn't say anything at all for this problem for these two equations, or these two parallel lines. But now we do know that the distance is 1.8 units. That's our answer. That's how far apart the two lines are from each other. So let's review all of this here. Okay. First, the distance formula, and you can do it if you have a graph. You could use a right triangle to figure it out instead. The shortest distance between a point is a perpendicular line, and that means we needed to find the equation of the perpendicular line, and then using the two lines to get the points, which we did here in this problem. We got the 2 points and the distance between those 2 points. In this problem, two parallel lines. We found a line between them, and it was definitely always better to start with the y-intercept line. Start with y-intercept. Big deal. That makes it much easier. Okay. So that's the starting point. And then we found the slope because they were perpendicular lines. And we could make one equation and two equations. Actually, we were given them here. Or use them together to get this point. So I'm going to draw it here to it. That's that point there. And now we just had to find the distance between the 2 points as 1.8 units. So there are quite a few steps to this. It's not an easy one to do. You just have to think about these 1, 2, 3 steps. Okay, so find the equation of L3, which means you needed to know these 2 points. And then find point 2. So you needed to solve a system of 2 equations. And so we got the point. And then we can use the distance formula to find the 2 points. I hope that helps for doing these kinds of problems. Thank you for watching and listening.